Jai Hind everyone. Myself Rupak Kumar from IT department. Today we just explain you in computer network unit 4 transport layer. In OSI model there are 7 layers in which transport layer is one of the important layer. Basically it consists a transmission control protocol, that is TCP protocol, which is responsible for sending the data over internet. Means when we are using internet throughout the world, all the system, all the nodes, all the connections connected with the internet is using this TCP IP. Means we can say more than 90%, 96%, I think 96% nodes or a computer which is connected in internet throughout the world is basically using the TCP IP protocols for transferring the data or sending the data over internet. Rest of 5 or 6% computers or node is using your SXPX, NetWI and many others protocols. But most of the computer throughout the world is basically depends only this protocols, that is what transmission control protocol. So it is a very important protocol in terms of sending and receiving data, in terms of university exam also. So today we going to know what is the transport layer, and in this we have it is basically process to process delivery. We cover the topic like in transport layer we cover the topic like TCP, that is what transmission control protocol. We have a process to process delivery, transport layer protocols, we have a UDP and TCP, then we have a multiplexing, connection management, flow control, retransmissions of data, window managements, TCP, congestion control and quality of service. So we cover all this topic in this video lectures. So first we start, what is process to process delivery? So basically process to process delivery is responsible for application to application, we can say. So process to process means application to application delivery of the data. So application layer, in this we have a position for transport layer. We have a application layer which is sending data from application layer to rest of the layer in the network. So we have a quality of service, and then we have a congestion control, then we have a transport layer. In a TCP layer we have some packaging, connection control, addressing, reliability, and that is what the reservation service for that. So first we see what is responsibility of transport layers, or we can say duties of transport layer: packaging, connection control, addressing and providing a reliability. These all are the basic important duties we can say of transport layer. So first we go for packaging. What is packaging? Packaging means to divide a long message. We just have a long message where we want to send over the internet. So at that long message is basically divided into a smaller ones. These smaller units are encapsulated, means it make a small unit of that large unit into a data field of that, and that is what we can say the transport layer packets and headers are added. Means in packaging we just divide a long message into a smaller ones, and this message is basically, then this is, suppose this is a message 1, this is message 2, message 3 and so on, message n. So we just take this message m1 and thus we can say we just divide this message to the we just make an encapsulation of this message plus some headers. Headers means that is what how we are able to send it in a network. So this packaging make the data to send over the network. Clear? So this is what we say the packaging is there. So packaging basically it's divide a long message into a smaller ones, and these smaller units are encapsulated into a data fields of the transport layer. So we can say the packets and the headers are added when the data is sending over network. Next is connection control. What is connection control? Connection oriented delivery means establishing a connection. We can say a virtual path. We just create a virtual path between the one node to another. if there is two nodes or two system, we can say in computer network, we can say system or node also. So when we connect two system or a node, we establish a virtual paths between that sender and receiver. This is the sender computer, this is receiver computer. We just create a virtual path between that. This is what the connection oriented delivery. We just connect one system to another system, and then we are ready to deliver the data at that system. So this is what we can say a connection oriented, means TCP IP provides a connection control, connection oriented delivery of the data from one node to another node. Next is your connectionless delivery. What is connectionless delivery? Means we can say it treats each packet independently without any connection between them. Means the all packet are independent, they are not connected with each other, and that is what the connectionless delivery. Next is your addressing. Addressing means to providing a reliability. Means we can provide a reliability of the application program. Means application program is most reliable. Means we can say we can have a flow control. This is not happen that data is sending, maximum data is sending throughout the small channels. This is what the congestion is there. So that's why we have to control the flow. So this is what the TCP which maintain the flow of data. Means data is not flowing as it is just flowing with some restrictions. That is what the flow control, and also responsible for the error controls. If there are any errors in that from one process to another process when we are sending the data, and it is also responsibility of the transport layer to controls the errors throughout the communication. Clear? So this is some important terminology. Next, transport layer. Transport layer is basically responsible for a process to process delivery of data. What is the process to process? Process to process means if we are sending data from some applications like WhatsApp, then there must be at receiver end, they just deliver to WhatsApp only. This is what the process means. In a system, in a computer, in a node, we have a different processes is there. At a time, there are several processes running. So the TCP is responsible for sending that data from one process to another process in a network. So this is what the important responsibility of a transport layer. Next is internet models. That is what has two protocols at the transport layer. If we are using internet over connections, then we have a two important protocol is there. And that important protocol is basically UDP, that is what the user datagram protocols, and another important is basically TCP. We are just on that transport layer only, but in that transport layer we have a TCP as one of the important protocols. That is what we just already told you, that it is the major protocol that was responsible for sending data over internet nowadays. Means 96% of computer user is using this protocols only for sending the data over internet. Next is process to process. What is process to process delivery? In process to process delivery, first we have a client server architecture is there. Means there is one client who is sending or receiving the data, and there is one server from which we are fetching the data, or we are just sending and receiving data from that server. So this is what the client server architecture in this. So process to process is basically a client server architecture. Next, addressing. Addressing is means there must be some address. Means every computer node in a network have IP address, must have an IP address, and another important is MAC address. MAC address is basically physical address. It is given by the providers. Means it is IP address is given by the ISP service provider, and MAC address is basically given by the equipment, or we can say node or a computer company, which just manufacture company of that system or a computer. So this is two address is responsible. Process to process delivery is also responsible for addressing levels. Next is multiplexing and demultiplexing. We also see, we just say how data is multiplex over a single channel over network, and then again demultiplex. Next is, it is a connectionless and connection oriented, already discussed, reliable and unreliable. So let's start with how the process to process delivery of data is take place. First we see, you can see that we have different network in the internet. So we can see this different network is basically This is what the one network in a internet, and this is what the another network in a internet. So when we connect a routers in a internet from another network internet routers, this is called basically node to node connections. Means one node or one routers from a one server and another node and another router in a different server, they are connected with each other for connecting the network. So this is what the node to node connections of the data. Next is your host to host, means the system. From this router we connect some system. There is several router, all router is connection means node to node, means. And next is there is a system or a server or a computer, and this computer is again connected with another computer. So this is what the host to host connections. But we are just focusing on process to process connection. That means in that system or a network, there is different processes running. Several processes running at both the side, from sender or receiver. And when we connect this system and that process, means the port number of this process to the port number or another process in a sender or receiver system, this is called the process to process delivery of the data. So this process to process delivery of the data basically is responsible for sending data from one process to another. As we have different processes, several processes running in a system or a computer at a time, and we can see this is how we connect this process, one process to another process in the network. So here it is written node to node, means it's a responsibility of data link layer in a OSI model. Host to host means it's the responsibility of network layer in a OSI model. Process to process means it is responsibility of transport layer in a OSI model. So we are dealing with transport layer now. So we are concerned with this process to process transferring of data. This is how the types of data deliver over a network. Clear? Next, what is client server paradigm? Basically, when there are several ways by which we can connect the computers. So several ways to achieve this process to process communication, which we are doing in a transport layer. So most common one is that through the client server architecture. So we are using one client is just connected with another server, and that server is responsible for sending and receiving of data. So a process on a local host called a client and need to serve from a process usually on the remote host or called a server. So this is how one process is connected with another process with the client server paradigm. Next is addressing. Whenever we need to deliver something, to specify destinations among a many way, so we need an address. So addressing is also an important part of this transport layer. So a transport layer, we need a transport layer, that is what addresses called a port number to choose among multiple processes running on the destination host. This is what addressing is a purpose. That is what destination port number need for the delivery, and the source port number you need for the reply from that. That is what acknowledgement is sending to that your destination port number to source port number. So these all destination port number, source port number, these all addressing IP address of destination number, source port number is very important. So this is all are responsible with the help of this addressing process only. Next, port number. Now we have a how the port number is given. Suppose we have a port number in a process 52000, and in another port number, another daytime client, we have a port number of 13. So this is how we write the port number. Means we have a data, then we have a port number, and then we have a data, and then we have a port number of that. Means when daytime client is sending the data, they just in a data packet or encapsulate data with the port number of the receiver and that and port number of sender. First we write the port number of receiver, then sender's port number. Again at sender's end, we just sending the data, that is what data, then the port number of receivers and port number of senders. This is how this port number is responsible. So we can see the port IP address, we can say have a different how the port number and IP address is inbuilt while we sending the data. So in this figure we can see if a data want to send from that 13 port number. So in an IP header, we have to encapsulate this port number with the IP address. Means sender just find this port number, selected port for the sending the data. So port number plus IP address is combinedly responsible for sending the data over network. Clear? Now INA range. What is the INA range? Basically, INA stands for Internet Assigned Number Authority. So INA basically divide the port numbers into three ranges. So first is well-known port number, second is registered port number, and third one is dynamic port number. Basically, there is a range of port number. We'll see in the next slide. This is what the range of port number from 0 to 65535. This is what the range of the port number. And when we see the 0 to 1023, this is what well-known port number. This is well-known port number means it's a previously defined port number. Means this port number is fixed. It is defined or given to the some of the source or some of the network where the data is sent. And next is your registered port number 1024249151 is basically registered to the INA, means Internet Assigned Number Authority, registered these range of port number for different servers. Like SQL server have a different port number. That is what range from this 1024 to 49151 port. Next and last port is dynamic port. Dynamic port is range from 49152 after registered port number to 65535. This is what dynamic port. Dynamic port basically we can say it's a private port number. If anyone want their process, their system to have some port number, their application to have a support number. So this is what the range of the dynamic port number means. They apply this port number, and that is what range from 49152 to 65535 numbers. Clear? Next, what is socket address? Basically, combinedly, when we combine a IP address with the port number, and that is what's combinedly known as socket address. So process to process delivery needs to identify IP address and port number at each end to make a connection. So combination of an IP address and the port number is called a socket address. So next is your transport layer protocols need a pair of socket address, that is what client socket address and server port address. This is what combinedly responsible for sending the data over the network. So this is what the socket address we can say. Socket address means means it's a combination of IP address and port number. Means when we combine IP address with some port number, this is what called a socket address combinedly. Next is your multiplexing and demultiplexing. The addressing mechanisms allow a multiplexing and demultiplexing by the transport layer. Means transport layer is only responsible for sending a different processes data at a single channels or a single network. This is what they do with the help of this multiplexing only. So multiplexing is basically many to one data sending, and demultiplexing is basically one to many. Means just we have a different many network over there. We have basically different process there. In every process we have data, and we just multiplex these data. This is what many to one and sending over a single channel. This is called a many to one, and here one data is coming from one source or one types of data, and that is what divided into many. So this is what one to, this is what one to many to, this is what many data to one data, and this is one data to many data. This is what many to one and one to many, and this is what called we can say it is a multiplexing, and this is your demultiplexing. Clear? Here we can see the things. That is what this is different process which is generating data. Multiple data is generated at a time, and this multiple data is just sent to the multiplexer. Multiplexer just added this data and send it to a single channels or a network, and that single channel network is just sending the data to the receiver ends, and at receiver ends it's a demultiplexing by which we can divide this data. Means if the data is coming from the port number 80, then this data is sent to the port number 80 only. This is what the different process responsible different ports, and they are just sending the data from this port to that. Clear? This is what the multiplexing and demultiplexing. Connection-less versus connection-oriented service. Connection-less service, basically the packets are sent from one party to another party with needs for connections establishment, or we can say connection release. So packets are not number, may be delayed or lost or arrive out of sequence. So no acknowledgement is there. This is what the connection-less. And if you talk about the connection-oriented services, that is what the TCP services. So first, a connection is established between the senders and a receiver. Data and transferred, and data are transferred, and that's what the at the end connection is released. So this is what connection services or connection oriented service. Connection-less service and connection-oriented service. Basically, UDP is responsible for connection-less service. Here we have a UDP, and here we can have a TCP. This is what the connection-less service is. It is a basically fast service. It is a connection-oriented but slow service. This is what the merits and demerit of these two protocols, we can say. Connection establishment. How the connection is established with this two hosts at a time. So we have a connection request from a side A, or host A is just sending a request to host B for a connection, and after that, when host B find this request, they just send the acknowledgement to the host A that we receive your connection, you can connect. Then again, host B is also sending a connection request B to A, and then host A is just sending an acknowledgement, yes, you can connect. So this is what how the connection is established in a TCP. That is what transmission control protocols. Now, if the process want to terminate the connections, so there is another way to terminate. Then the host A is just sending the connection release to message to a host B, and host B is then acknowledged for connection release from that, and again the host B is also send a message to connection release from B to A, and acknowledgement is again sent from A that you can disconnect the same. So this is what the responsibility of connection termination. So this is all about your TCP process, how the data is connected and establish a connection. Okay, we'll see next topic in a next lecture. Thank you. Jai Hind.